Have you ever asked an AI a question, got a perfect answer, and then asked it the exact same thing an hour later, only to get, well, complete garbage? It's super frustrating, right? It feels like you're playing the lottery. Well, today, we're going to fix that. We are moving away from just asking the AI questions, and we're going to start engineering instructions that give you predictable, reliable results every single time. We're going from chaos to control. And just a quick note, this explainer is brought to you by DevCredence. All right, let's dive right in. What we're really talking about here is a whole discipline called prompt engineering. This is all about crafting incredibly precise instructions for these large language models so you get exactly what you need. You know, it's the difference between being a passenger, hoping you get to the right destination, and being the actual pilot in the cockpit. So here's the game plan. We'll start by really nailing down the core problem. Then I'm going to introduce you to a really powerful framework to solve it. After that, we'll get into some more advanced techniques, and then we'll wrap up by seeing how this is all being used out in the real world. Let's get to it. Okay, so why does chatting with an AI feel so random sometimes? Here's the thing. The problem usually isn't that the AI is inconsistent. It's that our instructions are. We're basically feeding it chaos, and then we're surprised when we don't get order back. This is the million-dollar question, isn't it? And it all comes down to what these models actually are. They're what we call probabilistic engines. They're constantly, and I mean constantly, just guessing the next most likely word based on the clues you've given them. And there's actually a technical term for this chaos. It's called high entropy. When your prompt is vague, you're basically giving the AI a massive, wide-open universe of possible answers to choose from. Our job, as engineers, is to shrink that universe down to just one, the single correct one.
And take a look at this. I mean, we've all done this, right? We've written prompts like, read this email and tell me what I need to do next. It seems so simple to us, but for an AI, it is just riddled with ambiguity. What does what I need to do next even mean? Should I extract a list of tasks? Should I summarize the whole thing? Am I supposed to give you advice? This is a classic high-entropy prompt, and it is a recipe for disaster.
So how do we fight back against all this entropy? Well, we use a system. We use an engineering approach. And this is where we introduce the CORA framework. It's a way to structure our prompts so they are clear, so they're debuggable, and most importantly, so they are deterministic. Now, what's so cool about this is how each piece has a very specific job. Context is where you tell the AI who it should be, its persona. Output defines the exact structure of the answer you want back, like give it to me in JSON. Rules, these are your guardrails, the really critical do's and don'ts. And finally, execution. That's the verb. That's the explicit command. Put them all together, and you have a complete, bulletproof instruction. Now, just look at this transformation. It's night and day. On the left, you have that vague, high-entropy request. But on the right, you have a precise, engineered instruction using CORE. See, it's not a question anymore. It's a command. We've told it who to be, what format to use, the rules to follow, and exactly what to do. And the result of all that? Pure predictability. Okay, this next part is a really crucial professional habit. You have to always separate your instructions from the data you want the AI to process. Think of your prompt as code and the text you're feeding it as data. We use these things called delimiters, like the triple quotes or hashtags you see here, to build a clean wall between the two. This stops the AI from getting confused about what's in order and what's just information it needs to look at. So once you have the CORE framework as your foundation, you can start building on top of it to get into some much more advanced reasoning. For a lot of tasks, you can boost the reliability like crazy just by giving the AI a few examples. This is the big difference between zero-shot and few-shot prompting. Instead of just describing what you want, you actually show it one or two perfect examples of an input and the exact output you expect. This really anchors the model's understanding and just slashes the error rate. Now, for the really complex problems, the ones that involve logic or multiple steps, you can't just ask for the final answer. You have to force the model to show its work. This technique is called chain of thought. By telling it to first analyze the problem, then check its rules, then do any calculations, and only then draft a response, you're guiding its entire reasoning process. And if it messes up, you can see exactly where it went wrong. And listen, in a professional setting, looks good enough is, well, it's not good enough. You have to be able to measure the quality of the output. We break it down into 4 key dimensions. Was it factually accurate? Did it comply with all our rules? Is the output format, like the JSON, actually valid? And finally, Does it have the right tone and style? Because if you can't measure it, you can't really engineer it.
Now, I know this might all seem a little theoretical, so let's take a look at how the CORE framework is being used in some really high-stakes industries, like right now.
So in healthcare, a huge task is taking a messy, transcribed conversation between a doctor and a patient and turning it into a perfectly structured medical record, what they call a SOAP note. This has to be absolutely perfect. There's no room for error. And here is a perfect example of a critical rule you'd find in that healthcare prompt. This isn't a suggestion. This is a hard constraint to enforce legal compliance with HIPAA privacy laws. This shows you exactly how the rules in the CORA framework act as these vital safety guardrails. Okay, let's switch gears to banking. Here, an AI might be helping an agent figure out a customer's transaction dispute. And this whole process is governed by some incredibly complex financial regulations. The stakes are, again, incredibly high. Just notice the precision of the language here. The rules are totally non-negotiable, it has to follow a specific timeline, and, this is crucial, it's forbidden from making a final legal judgment. Its job is clearly defined: provide a risk assessment, not a final verdict. That is prompt engineering in action, managing risk and defining scope. This right here, this quote, really just sums the whole thing up perfectly. We're not trying to build some magical, all-knowing oracle. We are engineers. We're building a reliable tool by giving it a very well-defined job with clear constraints, a specific role, and a predictable format. It's about control, not chaos. So, I'll leave you with this question to chew on. Think about your own work. Whether it's sorting through emails, analyzing data, or drafting reports, what repetitive, kind of unstructured task could you transform from a lottery into a reliable, engineered process? The tools are right here.